So in this tutorial, I'm going to be doing effective debugging. In this year, we swapped the debugging and the coding style from the last tutorial. If you prefer this better than having the coding style first, feel free to give us feedback on what you think about the order. Because there is some discussions among the teaching team about that. Here is a quote that we want to share with you. Debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. Why debugging matters? Because there will be bugs. Even if you are writing the code as cleverly as possible, there will be bugs. Debugging and testing typically takes 50% of software development time. Not for just software, any complex system will need debugging. For example, for hardware development, debugging time typically takes about 70% of the development time. Debugging is a learned skill. You can learn to debug effectively over time. The system is not magic. You can understand it and debug it. It can be a deeply rewarding experience to debug if it's driven by curiosity and creativity, and the satisfaction of understanding a bug's root cause. So if you see something not working, do not think it's not working because something's broken. Try to find the root cause and fix it. Today, we're going to introduce 3 systematic approaches to debugging: the infection model, the wolf-fence algorithm, the detective method. We're then going to go into some demos to show you how to debug. First, the infection model. Software systems are causal. And what causal means is that every state of your program execution is dependent on some previous state in time. So are many other types of systems. If something happens in some time to one state because of some faulty code, usually this state will not result in the program end immediately. Instead, it will propagate. It causes an infection that spreads through the program state, and more variables will be wrong. Eventually, the infection will cause an observable failure in one of the states, like a crash, like it's returning a wrong number or something like that. Next, the wolf-fence algorithm. This algorithm is defined first to be the concept to find a wolf in Alaska. What it does is that it puts a fence somewhere in the space, and that it guarantees that the wolf is not in one side of the fence. We then continuously put on fence, and we start to take away spaces that we're sure that will not have the wolf. And we continue doing this until we eliminate all of the other spaces and we are left with a small space to explore. And that is usually how we can use to identify the root cause of some observable failure. The potential set of root cause is huge. You will have a huge set of variables that may or may not exist in some of the states where your program is executing. So you have to systematically eliminate possible causes. Say you have an observed failure here. At the end of the program execution time, and it failed here. What you want is to put on a wall fence at some time in the program execution that we can verify that all of the states are working fine before this time. So we eliminate that space. Then we put another fence to eliminate those variables that are not involved. Then we can look at the causes for this observed failure in the program execution time. And we verify those one by one after we have eliminated a large space. Then we know what is causing the failure. And this can be done because the program execution is causal. Another method is called the detective or scientific method, where you are debugging in a loop. Starting from observe that there is something going wrong, or is there something that you can see from the std out, std error, or you can inspect the variables with the debugger. But as the first step, you're looking at the std out and the std error. Hypothesis: make an educated guess about what could be the cause for the observed behavior. Like if you're seeing a seg fault, then probably it's caused by some memory. Something is trying to access some memory that is not valid. Predict what will happen if the hypothesis is correct. Then perform a controlled experiment to verify whether the prediction is actually what's happening. By rerunning the identical scenario in the debugger, then we loop back to observe and inspect the variables with the debugger. In this case, the really hard part is generating good hypotheses in this step. The goals for hypotheses are for them to be easily testable, quickly leads to the root cause. It may take several iterations, but it will eventually lead to the root cause. And this skill improves greatly with experience. Let's try to do a debugging walkthrough on the find street segments of intersection function. For example, if you're seeing something going wrong with this function, we have the global variable. That's a vector of integers, intersection street segments. And that's a vector that contains vectors for each intersection, the street segments connected to each intersection, as we did before. And here's the code. We have the helper function load intersection street segments extracted from load map. And in the actual find three segments of intersection function, we are returning from the global variable. And let's go to the demo. Five. Remember from last week, for your coding style, we want some comments like this with global data, helper functions, helper function declarations at the top, and the actual helper function implementation afterwards. For your load intersections, three segments helper function, we're doing same things as before, but we have intentionally added a bug into it. And here's the function itself. That's the only function we have implemented in this recall. Let's make. We make conf for release. And I'll do ECE297 exercise 1, run tester. Functionality intersection. So we're seeing 3 of 3 failed. What's the next thing to do? Can anyone give me any suggestions? Is there any suggestions? Okay, because the log is too long, I'll be redirecting everything into a log file. And I'll search for what this is saying for this function that we're implementing. That is intersection street segments. So it's this one. It's giving one line saying unhandled exception test crashed. And then it moved on to the second test. So this means that something is causing the intersection street segments test to crash. Now that's still not very clear on what happened. But we know that something is crashing. What's the next thing to check? Because something's crashing, the most likely cause is some memory issue. So I'll check memory by setting configuration to debug check. And I'll do it again. So we're seeing more from debug check. Since there is a vector related error of attempt to subscript container with out of bounds index 1, but container only holds one element. And this is happening to some vector. And it's giving some suggestions. Halted with sig abort. Likely causes memory corruption, assertion failure, could not parse tests. Exit code was -6. If you're interested, you could research on what the exit code means. As long as it's not 0, then something's wrong with your code. That's what debug check would give you. Now let me make clean and make with debug. And in here, instead of run tester, I'll do debug tester. Let's look at what debug tester is giving us. It's backing up the already existing tests to some old tests folder, copying the required test files so that you can see the unit test files under tests. It then says recompile the project in your IDE using unit test configurations. To debug, open the debugger in your IDE. To run Valgrind, use the following command. So what I'll do is I'll go into makefile. Please watch this part. This part is very important. I will set the configuration to unit test debug for the debugging configuration. The build target, I'll select all so that it generates all of the build targets. The launch target, I'll select test libstreetmap. It will not work if you don't do the same thing as what I had. And similar to what I did the last week, I will go into the actual unit test file where it has the test suite. It has 3 unit tests, 1 for intersection street segments. And there are 2 other test fixtures. I will delete the other 2 because I don't want my log to be flushed by something I don't need. I'll save it. I'll compile. If you don't compile with these configurations or launch with these configurations, it won't work. If we run this, we'll see that the test crashed with unhandled exception. 1 out of 1 tests failed. After I compiled this unit test, I'll run Valgrind using this command. Following what the output said, I will copy this command and run it. Remember to run Valgrind, I'm doing the debug configuration. Unit has debug configuration. So there's no memory leaks. One test failed. And this is a very, very long log from the Valgrind saying invalid read of size 8. So Valgrind is not really giving any more helpful suggestions other than what was given by debug check. Sometimes Valgrind gives more, sometimes debug check gives more. But in this case, both are not clear enough. So now, because debug checks and Valgrind are both giving us something related to a vector, and we're only running one test for the load intersections 3 segments. It's time to open the debugger. I'll set a breakpoint here. And because I already compiled, I don't have to compile again. I'll open up the debugger. Because it's something related to vector, debug check was telling us that we are trying to access a vector with index 1 that only has a size 1. So in my watch, I'm going to make a hypothesis that we're doing something wrong with this global vector. So in the watch, we can enter some expression for us to track over time. In this time, I will be doing intersections, street segments, dot size. And it's 0 originally. Then I'll do intersection, street segments, 0 dot size. It doesn't have a value yet because the outer vector only has size 0. I'll step through this function. So from line 58, the size of intersection street segments increased to 1. Let's step through. We can see that the intersection street segments 0 dot size is incrementing as expected because we're pushing back. And we exit the inner for loop and go to the second round of the outer for loop. And here's the exception, segmentation fault. If we look at the call stack, we can see these three call stacks are all called inside the C++ function, C++ library, so we don't have to worry about that. We find the first occurrence of our code, and here is where the exception occurred. In here, we are doing, let's see, what is intersection? Intersection is 1. We're trying to access index 1 of something that has size 1. And that's why we're having the seg fault. And why do we only have a size 1 for intersection C segments? It's because we are making an empty vector and pushing that back once outside of the for loop. So we don't want to do that. Instead of pushing back one copy of an empty vector, we want to change this to a resize of size non-intersections so that we can do direct access for all intersections, right? Is that correct? Is that making sense? And now, because nothing is using this empty vector anymore, save to delete it. After we made the changes, we can build again with the same configurations, unit test debug, and launching the test libstreetmap, build target set to all. Let's open the debugger again, and let's see the watch. So we are not at 1 again anymore. It's set directly to the number of intersections. And let's just do continue. Passed. 1 test passed. Now we can set back the configuration to unit test release again. Build clean and build current target. And run it. After we see that, let's set back the configuration to release and launch target to mapper. That should be our default configuration. And let's run the run tester. 2 of 3 failed. So we're passing one of the tests. Now, is everything I showed clear? So if you're seeing the test crashing, the first hypothesis is usually something's wrong with the memory. Then we can use debug check or val grind to have a hit. In the end, you can do the debug tester command to download the unit test itself and run the debugger. When you're running the debugger, you can set watch to anything that you want to watch out for that are not in the variables. But still watch out that something that's not available in the watch could cause your program to behave weirdly. So only watch for those variables that are already existed. That was my demo. Any questions up to this point? Next, let's go into Teams and let's do a debugging activity together. Say we have a sorter that sorts its command line arguments. So if you're calling this program with argsort 613, it should output 136. How the command line arguments work, which you should already know. Int argc is the number of command line arguments with main at argv0 and everything else afterwards inside our argv. And here's the code. We're making a vector to store all of the command line arguments like this. We input all the command line arguments. We pass the vector into the shell sort function. This function is written to work, but it's not written for you to understand. So it does something that should sort out the vector. And what argv contains is first the program name, then 613 in this case. Let's go to this link and try to fix all the bugs and try to use all three of those methods that we have discussed. I'll give you some time to work on it. After this, I would like each team to tell me what approach did you use, which approaches work, So first, what's wrong with this code? Can we get anyone to participate? What's the first problem with this code? You need to first run the program, and it's outputting nothing. So why is it outputting nothing? Yes? So it's not. So what's the first thing to watch for? Your output, right? It's doing from I to 0, I less than vector of sides, the vector of vectors I, and the vec is passed into shell sort by reference. Is there any hypothesis on what is happening? Yeah. So how do we check what's being added or what's being removed from vector? Here, right? Yep. It's not being pushed into vec. That's here. We push V in here and run it. So it's now giving something else. 016. It's given 613. But when we run it, we get 016. Yep. It's doing argc -1, but we want to change it to just argc and y. Why do we want to do that? It's not getting the last one. Let's see what happens. 0136. When you look at it, instead of starting it at I equals to 0, I started it at I equals to 1. And why do we start at x I equal to 1? Let's put a breakpoint here and enter debug mode. Start. Step over, step over. And let's see what's in RC. RC is 4. And let's see what's in RV. 0. In GDB, we have to use P. It's the program name. And starting from 1, it starts to have the actual input arguments. And that's why we want to skip over the 0. Let's stop this. That's how you can visualize each watch that you want to see. So in the for loop here, we want to start from 1. Let's run it again. And it's 1, 3, 6. And from here, it's working fine. Okay, so in the activity that just passed, what approaches did you use? Anyone use wall fence? Anyone use hypothesis? A scientific method where you propose a hypothesis, you test it, and you observe. Did you need to carefully read all the code? You have to? Carefully reading all the code is actually not very effective in debugging. Did anyone use wall fence? Yes, and where did you put the fence? Halfway through where? You put the wall fence where you are sure that it's working correctly. So when you are trying to get whether your deck is being filled correctly, you're trying to put a wall fence. Infection model? Remember, infection model is how, because your program is causal, then one error in your code will get infected into later states until it gets visible. And we all should have used hypothesis testing. We're seeing something, we're making a hypothesis, and we are verifying that. There are more resources on systematic debugging, wolf fence, and I hope this tutorial helps in your debugging for milestone 1. And that's it for today's tutorial. Thanks for coming. And if you have any feedbacks or preferences on whether you want the coding style to be first or the debugging to be first, feel free to tell me. Or if you don't want to, you can just anonymously post a note on Piazza and we can read it.